New discovery in science, and it's startling. Bizarre particles keep flying out of the South Pole, and it could break what physics knew up to now. There's something mysterious coming up from the frozen ground in Antarctica. It could break physics as we know it. This is what Scientific American reports. Physicians don't know what it is exactly, but they do know it's some sort of a cosmic ray, a high-energy particle that's blasting its way through space into the Earth and back out again. Now, they claim that most of these particles come in through the North Pole and exit the South Pole. But let's see. They blast through space, hit Earth, come into Earth, and go back out into space again. But why do they do that? The particles physicists know about, the collection of particles that make up what scientists call the standard model of particle physics, should not be able to do that. Sure, they are low-energy neutrinos that can pierce through miles upon miles of rock unaffected, but high-energy neutrinos, as well as other high-energy particles, have large cross-sections, quote-unquote. Large cross-sections, that means that they'll almost always crash into something soon after zipping into the Earth and never make it out to the other side. And yet, since March of 2016, researchers have been puzzling over two events in Antarctica where cosmic rays did burst out from the Earth and were detected by NASA's Antarctic Impulsive Transient Antenna, ANITA for short. It's a balloon-borne antenna drifting over the southern continent. ANITA is designed to hunt cosmic rays from outer space, so the high-energy neutrino community was buzzing with excitement when the instrument detected particles that seemed to be blasting up from Earth instead of zooming down from space. Because cosmic rays shouldn't do that, scientists began to wonder whether these mysterious beams are made of particles never seen before. Since then, physicists have proposed all sorts of explanations for these upward-going cosmic rays, from sterile neutrinos, that is, neutrinos that rarely ever bang into matter, to a typical dark matter distribution inside the Earth. References the mysterious form of matter that does not interact with light. The 18 biggest unsolved mysteries in physics. All the explanations were intriguing and suggested that ANITA might have detected a particle not accounted for in the standard model. But none of the explanations demonstrated conclusively that something more ordinary could not have caused the signal at ANITA. A new paper uploaded today said that this article, September 26, to the preprint server ARXIV, ARXIV, changes that. In it, a team of astrophysics from Penn State University showed that there have been more upward-going, high-energy particles than those detected during the two ANITA events. 3 times, they wrote, IceCube, another large neutrino observatory in Antarctica, IceCube detected similar particles, though no one had yet connected those events to the mystery at ANITA. And combining the IceCube and ANITA datasets, the Penn State researchers calculated that whatever particle is bursting up from the Earth, it has much less than 1 in 3.5 million chance of being part of the standard model. In technical statistical terms, their results had confidences of 5.8 to 7.0 sigma, depending on which of their calculations you are looking at. So this is breaking physics. Derek Fox, the lead author of the new paper, said that he first came across the ANITA events in May of 2018 in one of the earlier papers attempting to explain them. Quote, I was like, well, this model doesn't make much sense, Fox told Live Science. But the ANITA result is very intriguing, so I started checking up on it. I started talking to my office neighbor, Stein Sigurdsson, the second author on the paper, who is also at Penn State, about whether maybe we could gin up some more plausible explanations than the papers that have been published to date, unquote. Fox Sigurdsson and other colleagues started looking for similar events in data collected by other detectors. When they came across possible upward-going events in ice cube data, he said, he realized that he might have come across something really game-changing for physics. 5 mysterious particles lurking underground. Quote, that's what's really got me going and looking at the Anita events with the utmost seriousness, he said later, adding, this is what physicists live for, breaking models, setting new constraints on reality, learning things about the universe we did not know, end quote. As Live Science has previously reported, experimental high-energy particle physics has been at a standstill for the last several years when the 17-mile, 27-kilometer, $10 billion Large Hadron Collider was completed on the border between France and Switzerland in 2009. We're talking about CERN. Scientists thought it would unlock the mysteries of supersymmetry, the mysterious theoretical class of particles that scientists suspect might exist outside of current physics but had never detected. According to supersymmetry, every existing particle in the Standard Model has a supersymmetric partner. Researchers suspect these partners exist because the masses of known particles are out of whack, not symmetric with one another. Quote, even though the SM works very well in explaining a plethora of phenomena, it still has many handicaps, said Seda Ipek, a particle physicist at UC Irvine, who was not involved in the current research. He said, for example, it cannot account for the existence of dark matter, explain mathematical weirdness in neutrino masses, or the matter-antimatter asymmetry of the universe, end quote. Instead, the LHC, we're talking about CERN, confirmed the Higgs boson, the final undetected particle of the Standard Model, in 2012, and then it stopped detecting anything else that important or that interesting. Researchers began to question whether any existing physics experiment could ever detect a supersymmetric particle. Jesse Shelton, a theoretical physicist at University of Illinois at Urbana-Champaign, said, we need new ideas. And they told, Jesse told Live Science in May, around the same time that Fox first became interested in the Anita data. Now, several scientists not involved in the Penn State paper told Live Science that it offers solid, if incomplete, evidence that something new has really arrived. Quote, it was clear from the start that if the Anita anomaly events are due to particles that had propagated through thousands of kilometers of Earth, then those particles were very likely not SM particles, end quote, said Mauricio Bustamante, an astrophysicist at the Niels Bohr Institute at the University of Copenhagen, who was not an author on the new paper. Quote, the paper that appeared today is the first systematic calculation of how unlikely is that these events were due to SM neutrinos. Their result strongly disfavors an SM explanation, he said. And he adds, I think it's very compelling. Neutrino physicist Bill Louis of Los Alamos National Laboratory, who was not involved in the paper, has been following research into the Anita events for several months. A Standard Model particle created these anomalies. They should have been neutrinos. Researchers know that both because of the particles they decay into and because no other Standard Model particle would even have a fragment of a chance in a million of making it through the Earth. But neutrinos of this energy, Lewis said, just should not make it through the Earth often enough for Anita or ice cube to detect them. It's not how they work. But neutrino detectors like Anita and ice cube don't detect neutrinos directly. Instead, they detect the particles that neutrinos decay into after smashing into Earth's atmosphere or the Antarctic ice. And there are other events that can generate those particles, triggering the detectors. This paper strongly suggests that those events must have been supersymmetric, Lewis said, though he added that more data is necessary. Fox and his colleagues went on to argue that the particles are most likely to be a sort of theoretical supersymmetric particle called Stau-sleptons. I'm sorry, this sounds terrible. I'm sorry, I'm not gonna say what it sounds like. supersymmetric particle called tau-leptons. Tau-leptons are supersymmetric versions of the standard model particle called the tau lepton. The S is for supersymmetric, really. That's what it is for. Particle to neutrinos, the coolest little particles in the universe, sparticles. Lewis said that at this stage he thinks that level of specificity is a bit of a stretch. The authors make a strong statistical case that no conventional particle would be likely to travel through the Earth in this way, he said, but there is not yet enough data to be certain, and there is certainly not enough that could definitely figure out what particle made the trip. Fox did not dispute that. He said, quote, as an observer, there's no way that I can know that this is a STAU. From my perspective, I go trawling around trying to discover new things about the universe. I come upon some really bizarre phenomenon, and then with my colleagues we do a little literature search to see if anybody has ever thought that this may happen. And then if we find papers in the literature, including one from 14 years ago, that predicts something like this, then that gets really high weight for me, end quote. He and his colleagues did find a long chain of papers from theorists predicting that tau-leptons might turn up like this in neutrino observatories, and because those papers were written before the Anita anomaly, Fox said, that suggests strongly to him that those theorists were on to something. But there remains a lot of uncertainty on that front, and he says, right now researchers just know that whatever this particle is, it interacts very weakly with other particles, or else it would have never survived the trip through the planet's dense mass. So what's next? Every physicist who spoke with Live Science agreed that researchers need to collect more data to verify that Anita and IceCube have cracked supersymmetry. It's possible, Fox said, that when IceCube researchers dig into their data archives, they'll find more similar events that have previously gone unnoticed. Lewis and Bustamante both said that NASA should run more Anita flights to see if similar upward-going particles turn up. Bustamante said, for us to be certain that these events are not due to unknown unknowns, say unmapped properties of the Antarctic ice, we would like other instruments to also detect these sort of events, end quote. Over the long term, if these results are confirmed and the details of what particle is causing them are nailed down, several researchers said that the Anita anomaly might unlock even more new physics at the LHC. Quote, any observation, a non-SM particle would be a game changer because it would tell us that which path we should take after the SM. The type of supersonic particle they claim to have produced the signals of leptons are very hard to produce and detect at CERN LHC. So it's very interesting if they can be observed by other types of experiments. Of course, if it's true, then we expect a ladder of other supersymmetric particles to be observed at the LHC, CERN that is, which would be a complementary test of the claims, end quote. In other words, the Anita anomalies could offer scientists key information necessary to properly tune the LHC to unlock more of supersymmetry. Those experiments might even turn up an explanation for dark matter. Right now, Fox said he's just hungry for more data. This is originally from Scientific American. It's also on Live Science and other articles, and I'll leave links below for you for this. Images are from NASA.